You ever had an idea and you just can't shake it out of your head? You just have to share it. Well, I have one and I want to share it with you. I dreamt I was actually teaching in this room, filled with 3D SketchUp models, D2L, sandboxes, 3D printers, and some very motivated students. It all started with this little Y that this action figure is holding. This is history in the making. We finally made a small hollow fitting that can actually work. Now, I've realized we can make many of them, and yes, we can replicate enough of them to build something like this test lab model. Instructors Dennis Turk and Darcy Knight constructed this real-life shop project from this 3D design. I call it our transparent test lab. It's been designed to test the limits of the venting of atmospheric pressure in a plumbing system. They've even installed valves on all the vents to wreak havoc with the plumbing in this lab. We can do more of this, and we already have. Check out this second-year prototype already under construction. We are going to show off this G.I. Joe-sized house along with D2L at the Canadian National Apprenticeship Conference this spring. Here's a quick view of our temporary lab. We've been working on this gem with the help of the construction and architectural department, namely thanks to Garth, Luigi, Blair, and William, instructors and chairs from these departments. Now on to our third-year project. This one brings out the Lego in students. You can actually have running water through these pipes. It's living plumbing and students can build it all before they try out our shop projects. Yep, these are 3D printed models and 3/4 inch PEX pipes acting as 3-inch drain pipes for this simulated model. Check out these guys. This guy is trying to text his bro how cool this lab is. This other guy is stretching just before he's going to tackle his next Resi circuit vent assignment. Code is learned through designing and building different layouts, and this is how we start. We start from the ground up. Apprentices will build different underground layouts in each of these sandboxes. This is the painted 3/4 inch PEX pipe we have already used for model drainage in our prototype house. And check out these tools. That's basically all we need. That's a lot less than a normal shop. All that's missing from this cabinet is some glue and epoxy. We can use the paint from this cabinet to actually paint the gas pipe on this 3D SketchUp third-year gas project. Now, finally on to our already planned fourth-year project. In our current curriculum, this 16-page blueprint equipment list comes with our fourth-year modules. We study it as well as this K-12 layout of commercial kitchen equipment. But now we have our own 3D mini kitchen complete with fully plumbed-in kitchen equipment and bathrooms. Check out number 64. In real life, you could cook an awesome barbecue chicken in this state-of-the-art combi oven. These bathrooms illustrate how commercial circuit venting works. This assignment can be turned into a student-assembled model and then into a real-life shop. To construct this, all they have to do is walk across the lab and pick out their 3D printed fixtures, right down to a mini gas meter. Now you may ask, what will this take? All we need are rolls of 3D, PLA or similar plastic and the required 3D printers. To do this type of work, we could use printers that range from $500 to $5,000. Printers similar to this banged up a notch printer can print out more technical fixtures such as boilers or like this high efficient furnace, complete with an AC coil. We can hook up simulated gas, venting, and ductwork to these appliances. Now printers can also print out this SAIT plumber that was later painted by one of our instructors, Brendan Toner, from our plumbing department. Printers can also print out several fittings at a time over a 24-hour period. Yes, we could fill up all our shelves with 3D printed fittings. Yes, this is what this lab would even look like for trade shows. Now let's get on with our original Cadmus idea. This idea was to build a 5-story commercial building that many different trades could have input in. Carpenters can build the frame. AC and HVAC instructors could design the ducts. Architectural could design the building. Electrical could wire it. Many trades have shown interest. Now I have to admit to you, this has been a growing idea. What I really want you to do is endorse our construction department to do much more than a model. I want the Cadmus to kickstart us into building this lab. This will be a permanent part of what SAIT offers to construction trades. It can benefit several departments. SAIT can be the leaders in digital building technology for apprenticeship trades. We can do this. We need your support. In closing, I hope you will endorse this future multi-department 3D lab. If we don't do it, someone else will. We can do this.
You get one underneath.